People on Zoom, can you tell me if I'm audible? Okay, yeah, thanks, Christopher. Okay, we'll get started. Okay, so let me share. So I'll post the link of the GitHub page for data engineering in the chat. So once you go there, I'll tell you where to go. So, okay. Yeah, and once you're on this page, you click on this workshop 707 workshop for, yeah, I put the date wrong, but yeah, just click here. So let's say if I click here, if you open this Jupyter notebook, and then it will have this option of saying open in Colab. And then if you click on this open in Colab option, it will open the notebook into your Colab, and then we can get started. Yeah, please let me know if you have any questions or trouble opening this. But if you have opened this, then hey, for people who have just joined, I'll put the link again in the chat. So what you have to do is open this link on GitHub, and once you open it, you will see this option of saying open in Colab. Once you click here, this will open the notebook on Colab, and then we'll get started. So you can just give me a thumbs up if you have reached this stage. Yeah, if you've opened this Jupyter notebook, you can start by installing these 4 libraries, which we'll use today. Okay, so till the time it's getting installed, we can go and look at what we are going to discuss today. So today we'll be talking about Hadoop and Hive, which are distributed data processing platforms, and then we'll see like how Hadoop and Hives are different. So first, let's start with Hadoop. So Hadoop is a open source framework for distributed data processing. And what it does is that it takes your data, breaks it down into different chunks and like different blocks, and then process it across different nodes in a cluster. And the image you see on the left is a guide to like what tool you should be using when you have, let's say, data varying from different sizes. So for example, if you have just like very small data, like in megabytes or kilobytes, then you can easily process through Excel. If you have, let's say, about like 10 gigabytes, then you can use Pandas or maybe Apache Spark, which we'll be discussing in the next lecture. And if you have data, let's say, into 100 gigabytes or even reaching 1 terabytes, then probably you should be looking at Hadoop or a Spark cluster so that you get the most benefit out of distributed processing. So the core part of Hadoop is known as the Hadoop distributed file system, which breaks your data into different chunks and store it into different clusters. So we'll see one example where I have 3 servers and how the data is arranged into them. Okay, and the processing part of Hadoop is called MapReduce. So we'll also see like what's MapReduce algorithm and how it works. Okay, everyone good till now? Okay, moving on, we'll look at the core components of Hadoop. So like I mentioned, Hadoop has a file system which is known as the Hadoop distributed file system, and it can run on like commodity hardware like servers and have a higher fault tolerance. And the file system has the functionality for arranging your data into different blocks. And the processing part is known as MapReduce, which splits it like, so when the data is split between different blocks and processes, so what it does is that since your processing may not be in like one serialized order, so that it can be broken down into parallel chunks. So what MapReduce does is that processes the data in parallel. Once it gets the result, it just clubs them together back and gives you the result. And Yarn is the resource negotiator for HDFS, which allocates system resources based on how complex your process or queries are in the Hadoop ecosystem. Okay, and in the image, we have this example of one name node and data nodes. So your file is divided into different blocks. So let's say I have like an Excel file having, let's say, 1,000,000 records, then it will be broken down into different chunks of the HDFS file system, and then different blocks will be stored and replicated into different data nodes. And once you run a query, so the client connects to this name node server, and this name node server directs the data node servers to go and run the query and fetch the data and put everything back together. Okay, next is introduction to Hive. So why Hive was introduced here? Because Hadoop and this everything like MapReduce is written in Java, but the issue was that not everyone has the knowledge of Java. So how do you go about using this? So then they introduced Hive, which is a data warehouse tool built on top of Hadoop. What Hive does is that it gives you like an abstraction to query your Hadoop and the MapReduce algorithm. And for that, it provides you this query language called HiveQL, which is very similar to SQL, the structured query language. So what you can do is you don't really need to know Java to run Hadoop or MapReduce. You can still use Hive, which will kind of translate your SQL queries to Hadoop code and run them and then get the results back. And the benefit of this approach is that users or clients who have even if they have very basic knowledge of SQL that we see today in the tutorial, you can easily run your queries to get benefit of this distributed processing. Yeah, and the key features and use cases of Hive is that it like I said, it just gives you a mechanism to query using structured data, and you don't really need to know Java or MapReduce to query your databases. And the use cases is that it's used in data warehouse applications where like when the data goes into, let's say, terabytes or petabytes, then the real benefit of Hive, you can you can benefit out of Hive. Yeah, another thing is that it has very nice integrations with other frameworks such as Spark and other tools in the Hadoop ecosystem, so that you can, once you get the data out, you can have this apply machine learning or predictive modeling to it. Yeah, so let's go back to the Hadoop example here, that what are the core components of Hadoop. So right now I'll show you that how I set up things. So for example, let's go and see my Google Cloud Console here. So right now I have three virtual machines running on my Google Cloud, which is this cluster 6301. This is your main node, which means that this is the main node. By main node means like the name node, yeah, and where the clients will be connected, like once we run the HiveQL code. And this VM is connected to these two worker nodes, uh, this W0 and W1. And these are the nodes which will be processing the data and then outputting the results. And then this cluster node will be putting everything together and give the results back. Okay, so if you have this notebook open, and once you have installed all these libraries, we can import them together here. And what this does is that the Spy Hive gives you like a connector to connect to this database which we have available on Google Cloud. and this has an external IP. So the benefit of external IP is that we can connect to this database which is running on Google Cloud from our own machine. So by mentioning the IP and the 10,000 is the port number on which Hadoop runs. So once we run this, it says that okay, will get connected. But the difference here is that we will only get the connection to the main node which runs the Hadoop. So let's say we run it, it doesn't give us error. But if I change this and try to connect to the worker node, we should be getting an error. Yeah, because the client doesn't really have access to the worker nodes. The worker nodes are specifically designed to process the data and uh, give the results output to to the main node. And same thing happens, let's say if we try to connect to the worker node number 2, we should be getting an error. Yeah, so this demonstrates that we will be connecting to the main node. We do not have access to the worker node. We can actually get the access. Let's say we would have to do something in the backend. So like Google Cloud provides us SSH options. So we'll be using them at the end of this tutorial. But for now, we'll just connect to the main node and then try to run some queries. And once we have connected, we can have this connection cursor, which will connect us to this database, the Hive database, and by using this command. So this is the actual show databases command, which normally is like it's very similar to SQL commands, but so similar structure can be used for Hive query language. And once we run this, we'll see, okay, what databases are present. So when I initialized Hadoop on the backend, it comes with a default database which is empty, but so and then I push some data for this tutorial, and this data is available in this health data database. And now to use this database, what we can do is run this query called use health data and then put it into like in a string format, pass it to our cursor.execute, and it runs and says now it's using health data. And once tell uh, the program PyHive that okay, we have selected this use health data database, then we can look at the tables inside to just to see that okay, what tables are there. So once we run it, it tells us that there are 3 tables in the health data database, which are medications, observations, and patients. So this is the same data set where I'm using right now. We had the same database in our SQL tutorial 2-3 weeks ago. And yeah, and then once we are connected and we know what tables are there, we can run queries very similar to SQL. The only difference is that in PyHive, we don't really have this semicolon, which is usually used in SQL queries, that you end your queries with a semicolon here, but in PyHive, they don't end with a semicolon. You just mention things into a string and pass to your cursor object. Yeah, so once we run it, we are right now putting this command describe patient and asking, okay, tell me what different columns are available in this patient table. And after running this command, we are seeing that, okay, there are like different columns like ID, birth date, death date, and so on and so forth. All these columns are present in the patient's table. Similarly, we can run for medications here and then for observations here. And now it's very similar to what we followed in our SQL tutorial, that we would like to know that, okay, run some queries. Let's say we want to know select some patients from our patient table and then limit them to 20. So once we run this, it will take some time and then it results that, okay, these are the top 20 patients in your patients table. Okay, now we can go and look at what happens at the backend once we run it. So what we can do is copy this here in PyHive. Okay, and probably you won't be able to do it because I have the SSH access here. So, okay, uh, yeah, I'll stop sharing and open a terminal again. This one, yes. So now using the browser-based SSH, I am into the server connected onto the main node here. And what I can do is right now just say Hive. So once we run this, it will start Hive on the backend. Yes, and now we are into the Hive session. So to start, we need to first tell it that we need to use this health database. Yeah, to run queries in Hive, again, you need to have the semicolon now. So it say, okay, we are using Hive now, and took us like almost 0.5 seconds to run. And now we can go back and run this query. Yeah, this is just to demonstrate that once you run PyHive, like what happens on the backend. So we have it here, and then we can just say. So once we have this command, it just prints out, okay, like what happens here. So we see that, okay, we have the same commands here and both on our PyHive and at the backend. Just like we can just, so doing this, we can ensure that whatever data we are getting from PyHive is actually the correct data. So let's put it down for us. And then just go back to our original notebook. Yeah, here. Okay. And similarly, now we can know that, okay, let's count the number of patients in the patients table. So again, the command is similar to the SQL. It's just that there is no semicolon here. And once we run it, let's say run for some time and give us the result. I think it's a very large table and it's doing a full table scan, so it's relatively slow here. While it's running, what we can do is copy the same command and put it on the back end to see what happens here. And once you are on the terminal again, see. Yeah, so here you can see the actual how MapReduce works is that when we are running, there is a one mapper and one reducer they are running. And now they have provided, okay, this like 124151. So these many, about like 124K patients are there in the database. And it ran very fast here because we are actually running on the node server, but here we are connecting through and still running. Yeah, to get to that server only, like I can get it because I started those server, but it's not for the client. Client only can access through like deep using PyHive. Yeah. Yeah, it's just for like demo. It's just for demo. Like, okay, if you want to run something, you can directly run onto the node server by logging into from Google Cloud. Yeah. So let's say if you have something that you are trying to set up something, then you will be able to do it. If you have this technique for your own data and let's say you are a database administrator, then you should be able to go and do that. So like the database that you have already uploaded on. Yeah, so this is like a synthetic COVID-19 database, which is available. So what I did, I downloaded the CSVs and then pushed it to Google Cloud just for this tutorial. Yeah, yeah. So for that, I had to just like log in on the back end and download the CSVs and then first make the table into the database and then push it. Yeah. And then I've done like this before where it keeps running. And yeah. later I get a thing that says memory problem or something, so then. Yeah, so if it's a very big thing, then that depends on your current machine. That whatever data is coming from the main node, is your machine able to store it completely? Yeah. That's why just we are doing it on Colab. Like sometimes Colab has like good enough resources to run these. Yeah. Yeah, I actually had to do the HPC. Yeah. And then I opened the Colab on there, and then I guess you can set like the memory. Yes. It is like 30 gigabytes. Yeah, and then yeah, right. So in this case, if you were to do that, it would be faster. Yeah, probably. Yeah, I think it also depends upon how far your server is located, because right now on SSH, I am directly connected to the server. I'm directly using the server, like right now using SSH. But what here you are doing is you have a collab session running somewhere else, and now you're connected to the database, which is located, the machine is somewhere like US Central or East somewhere. So it takes a while to run this. Yeah, because yeah, so it's an issue with like connectivity. It's not because we just saw that if you run the same query on the backend, it just runs very quickly. Yeah. Yeah, I think we need to kill it, but let's say if you're running this, you can let it run. It's not giving us output. Yeah. Okay, moving on, similar to the SQL queries, we can find out. So like, let's go back and look at the different columns in the patient's table. We had IDs, birth date. So this is like a typical example of a patient table you may find in like a clinical setting in a hospital, which contains all the information about patients here. That and then their demographic information and and something about their insurance also, that what is their healthcare expenses and coverage here. So for example, let's say we now need to know that, okay, how many cities or distinct cities are there to which all these patients belong. So if you run this, should probably run this now quickly. Okay. So actually, is there a way to know like how much time it will take to finish, for example, on Colab? No, I Colab, I don't think so. Yeah, yeah. Here the only difference is that the once I log in, then I can directly run queries on the node. But here it's just like I'm connecting to the node via some other computer, which is your Colab. Yeah. But ideally, what you would do is, let's say you set up things somewhere, then you should be able to provide like direct connections to the server. Yeah, then it should run faster. Here right now, I think it runs very slow. Yeah, and it's like so the only like the real benefit of using Hadoop and Hive comes when you have, let's say, data in like terabytes or petabytes. So if this were like a terabyte level database, then if you compare both Hadoop Hive versus SQL, then Hadoop will give results faster. But if the data is like megabytes, this is like around like 700 megabytes or so, then you may see that SQL gives you faster results. Yeah. Yeah, there was some error. Hmm? Some symbol. Yeah, some symbol got wrong. Yeah, that's yeah. Mm-hmm. Yeah, sometimes it happens in Thrive. I mean, I don't know. I think this we can just move on and see the other queries. Yeah, which is not able to fetch. So yeah, we can run the other one. Yeah, so in this query, we are trying to see the distinct city and gender. And once it runs, should be able to have some results. It's running very slow today. I don't know what's happening. Yeah, that's true. Like if you run the same query like on the backend, again, it will just run very quickly. Okay, let's try to run it on the backend. Let's see just for demonstration. Maybe connect it in here and yeah, I think here also there are some issues. Okay, let's go back to Colab. Let's try to run this one and see what happens. It ran, and if you see the top first 10 results, then yeah, we should be able to see that, okay, we have the first name, last name, gender, city, and passport. Sometimes the passport is empty here for all the patients living in the city Springfield. And then similar to SQL queries, we can have multiple conditions in the selection. So for example, we would like to know for all the patients in the city Springfield and their gender is female. Then we run this. Yeah, it still takes a while to run because it's just sweeping over the full table. And then we look at, we have all the female patients living in the city Springfield. We can have a nested selection similar to what we have in SQL, that now you would like to know for all the gender female and city Springfield or city Boston. Yeah, so now we have all the patients who belong to either city Springfield or Boston who are female. Okay, and now we can also look at like filtering on missing data. So for example, in the previous one of the previous queries, we had some of the columns who didn't have a passport number. So we have to filter some people who don't have a passport number. So you can just uh, call this query here, where we can say is passport not is null, is it an empty string or an empty string with a space. Yeah, once it runs it, you can just print it and see now it has filtered out uh, patients here. Let's say, for example, Golden Polish, this person, she lives in Springfield but doesn't have a passport number here. So once we run this query, she is not present in this output where we have all the patients who live in Springfield who are female. Uh, no, only living in Springfield and having a passport number here. So we are filtering out on the column where they don't have a passport number. Okay. Similarly, for numeric range, we can have similar SQL queries. So, for example, we want to know their healthcare expense between 1.5 million to 2 million. So, you can just run this query here, which says select all these columns wherever you find city matching to Springfield and their healthcare expenses between 1.5 to 2 million, and we don't put a semicolon here. And these are the list of patients uh, who satisfy the filtering criteria here. You can also limit the number of queries returned. So for example, here they were around like, uh, uh, let me see, around 129K patients. But now we would like to know, just filter the top 20. So we run this and it filtered all of them. And it returned us just like 20 top results here. Again, what we can do is order by, and then while ordering, can order them alphabetically using their last name in different orders. So right now we have an example of ascending order. So once we run it based on the last name ascending order, we'll see all the Abbotts appearing together. Yeah. So right now we see like based on the alphabetical ordering of the last name, we see all the Abbotts appearing together. Okay, we can do the similar thing by order by descending. So instead of last name in the previous query, we can order them on the first name. And yeah, once we run it, this like descending order. So we'll see from the bottom. Yeah, and then this person Oscar comes in, but since they have this special kind of O character here, so that's why we didn't see any person appearing with Z, but now this character is like the at the bottom from when we arrange this into a descending order. Okay, now we can have patients. We have this example of group by. So the one example to show group by is count number of patients by city, and then group it according to the city. So once we run this, will just tell you that okay, uh, given our 129K patients, what's the order like? Which city has what number of patients? Okay, once we run this, we can just see like the top number here, and it arranges in alphabetical order here. Okay, and now what we can do is use both uh, group order by or group by or just the count, and then see what's the patient count here. So we run it and see count patient by city, and now order them from highest to lowest. So and then we are filtering the results by top 30. So we'll see the top 30 cities which have the highest number of patients. So we see, okay, Boston has the highest number of patients, around 11,500 in our data. Okay, and now we can have multiple conditions into our group by. So right now we are having, just want to know that, so we had Boston with 11,496. So how many male and females are there into the database? So once we run this query, we should be able to see, because it arranges them by the number of patients. Okay, and so now we can see, okay, for Boston, since it was the first city, and now this query breaks the total count here into two parts, and then we see female and male for, again, for Worcester, for Springfield, for Cambridge, and so So on and so forth for each entry here. Instead of just printing out a number of patients based on our query, it just prints the male and female numbers as well. Okay, now we can look at another table, which was the observations. So this table has data about observations. For example, let's say like heart rate or breathing rate, and let's say all these patients, let's say they had uh, some experience in the hospital, and when they were there inside the hospital, uh, or in the ICU, then there were measurements taken, and that measurement is inside this observations table. And based on the attributes, we see what's the date, the patient ID, and this patient ID matches to the patient ID in the patient's table. And then we have encounter and code and description. So for example, description could be heart rate and the value, like what was the heart rate and what was the unit. So now let's say we want to have the average heart rate by patient. So we can run this uh, complex query where it looks like filters out on the description table that, okay, we just fetch all the entries with this heart rate and then do a order by on the patient ID that what was the average heart rate. And then sorting according to descending. So descending means that we'll have all those patients with the highest average heart rate inside the database. Yeah, the result is out now. So here we can see some of the patient have the average heart rate like 200 beats per minute, like which is like very, very high. So, and since we have arranged into a descending order, that's why we see the 200 is like the highest number here. And now what like other things you can do, since you know that, okay, these number of patients have the highest heart rate, the average heart rate is 200, then using this ID, you can query the patient's table and see, okay, what are the attributes of those patients who have this uh, the highest average heart rate. Okay, now we can look at another table, which is the medications table, which contains like what whenever those patients were inside the hospital, what medications they got. And so that different columns we have start of the medication, stop, and then the patient ID, who paid for it, what encounter was there, description of the medication, what was the cost of that medication, and the coverage from the payer, and the total cost of that medication. So we can use this information to find out, okay, what are the top 10 most common vaccines, or because it's all into one table, so we can look at what medications. I think it should be medications. Yeah, what are the top 10 common medications? So what we can do is count the number of medications which appear inside the table and then order them by in a descending order and just limit to 10. Yeah, so once this runs, now, okay, we have the result now. It says that this hydrochlorothiazide was given the most number of times. Then you have this insulin dosage. Then you have the same as which appears in the first, but it is given with a combination of different drugs. So that's how you can say, okay, which drug was used the most number of times. Okay, going back to joins are are very common operations in SQL, and I have mentioned or give a detailed view of all the joins in the SQL tutorial, so you can look back It's on our data engineering GitHub. So if we go back and open this uh, here, if you go, and it has the SQL part 1 and 2, both has lots of examples of join, so you can look back here. So now we go back to our workshop again and see just one example of join, which says that we'll do an inner join, and the question we are asking is which medical treatment have been administered to patient, including the patient name and cost. So, and why we are doing this? Because this medications table here doesn't have the patient name. You just have start, stop, patient ID, and payer. So you would like to know, okay, which patient got the different kinds of drugs. So what you can do, then you have to do a joins, because this hydrochlorothiazide came in like the first, like the highest number of times. You would like to know, okay, which patient got it and when they got it. So right now, and this patient has like multiple entries inside the observation or the medications table. So once we're in, we'll see this person Aaron got it the most number of times. Yeah, joins are heavy operations. It might take some more time to run. Yeah, it ran the query. Now it's fetching the data. Be able to see the results. No, it's still fetching. I don't know. So Christopher has a question for your Google. Could you recommend setting the GPU window? I don't think uh that it doesn't really matter for GPU nodes because we are not using them. So running for SQL, I think CPU nodes are okay. Yeah, that this is an issue with like the free versions of Colab, that we don't really get like good network bandwidth, and then you have to pay like $10 to go to Colab Pro. Yeah, does it answer your question, Christopher? Yeah, I can add that. Um, I've used Colab Pro before, but it doesn't really make a difference in terms of mm, the connectivity. I think it's still the same.
Yeah.
And then, I mean, CPU nodes you can run for a longer time, but GPU nodes is like if you can, I don't know what time you can run, and then the free credits will quickly over. Yeah, maybe we should kill this and move forward. I think it's very slow today. Okay, we can look at concat functions here. So what we're trying to do here is just concat the first name and last name with a space. Yeah, so these are all string functions or different. Okay, just give me some error. Let's see. Okay. Now it has started giving error. Mhm.
Yeah.
Well, some of the names do have like accents, right?
Yeah. José Eduardo.
So maybe that's the issue. I can just try to run the other query. Maybe I think is it still because of some library issue? Because for some query it runs correctly. Until it runs, we can go and look at the Hadoop file system now. These are the last two commands remaining. So instead of Hive, we can go and look at how the Hadoop ecosystem is designed. So it will be again like a demo that once we have this command, we can just go back to my backend again here. Okay, and so now what is doing a HDFS file system check. Yeah, and like we discussed here that it has 2 data nodes and 113 directories, and then and now we would like to see, okay, there are like 32 files and how many blocks are available. So there are like 57 blocks, and then it also tells you if your system is healthy or not. So it says that, okay, the file system under this root for the HDFS file system is healthy. So this also tells you about the status here. And next we can look at the CSV files. So the CSV files are located in the user Hive warehouse, since Hive is a data warehouse. So, and then once we run it, it will also tell me, okay, what files are there, how many blocks are there in the locations. So now we get like a very detailed information about what's the replication, since we have 2 nodes. So all the, and when we had 3 CSV files, so this medication.csv has these many blocks, and they are located at this node, and it's replicated 2 times. Same with this observations, because it's a bigger file, so the number of blocks are more here. And it's also replicated as 2 times here, and they are present on the different nodes. And then different blocks are present on different nodes. And then same goes for our patient at CSV, since it's just like a very small file, it's present into 1 block. Yeah, and then it says here, okay, we have total 28 blocks here, and the file system under this path is also healthy. Okay, and another command is this report. It will give you uh, a normal report of the HDFS file system. So you go and paste it and then put it here. Yeah, so all these methods are for the backend user who is like a database admin and just want to know uh, uh, if their Hadoop or HDFS system is working correctly or not. So let's see what information we have. So right now we see that, okay, the total configured capacity of all the whole cluster together around like 100 gigabytes, where uh, right now we have used only 10% of it, and then uh, the capacity is like total 64 GB, so there's remaining. So what we can do is like put more files into it, and now and then we get the status about our data nodes. So these are the internal IPs for these two data nodes to which the main node connects. And then we can see each data node has like around 50 gigs of configured capacity. And then DFS uses some like 3 gigabytes, then non-DFS like 14. So, and so this will tell, okay, and there are like 57 blocks on each of the nodes. So this can tell you that, okay, what's the status for each of the nodes. Yeah, we're going back to our tutorial. Yeah, I think it's still running and there's some issue. So guys, that's it for today's tutorial. I'll see you next time in this Spark tutorial, which should be easier than this because we will be using PySpark and then we will be using like some Parquet files. So it should be similar to how you use pandas. So that should give you less problems compared to today. Thanks for joining.